Encountering preventable technical issues when running HPLC experiments can wreak havoc on your entire day, put you in a bad mood, and even worse, set back your project deadlines or timelines. So some simple things like checking your instrument for errors and issues, checking the purity and freshness of your solvents, and also checking the freshness and purity of your samples before you inject them are some important things that you can do to avoid technical failures when you do your runs. At the end of the day, good manufacturing practice and good laboratory practice always pays off. Always. Hi everyone, my name is Dr. Kimberly Lincoln, and today I want to give you 7 tips for things that you should double check before you run any HPLC experiment. Now the first thing, number 1, that I want you to check is the pressure of your HPLC system when it's on and before you inject your sample. Typical pressures for an HPLC run anywhere between about 5,800 psi to 7,000 psi. And this parameter is really important because pressure is what drives your mobile phase. So you inject your sample to the injector, and then it moves through from the column to the detector. And it's the movement, the continuous movement of that mobile phase that allows for your samples to reach the column and the detector. So if you have issues with your pressure, then you need to double check your instrument and try and troubleshoot what's going on, whether it's a leak in your line or a blockage in your column. Now the second thing that I want you to double check is the cleanliness of your column. So if you have a blocked column, or if you have a column that still has residue from a prior run, that's just not going to be good for your run. So what you want to do is perform a flush on your column. And you want to do this with 10 solvent volumes of the column before you run your experiment. And if when your flush is coming off and you don't see any peaks coming out on the detector, then that gives you the clear that you can go ahead and run through. If you want to be double cautious, you can first run a gradient or a solvent of what the prior run was, and then you can run your solvent system through the column. Either way, double check and make sure that your column is clean. Now the third thing that I want you to double check is what solvent was used in the run that preceded yours. So HPLC instruments are used multiple times a day by multiple operators, whether you're in academia, whether you're in industry. And so if there's no operating procedure put in place for proper cleaning of your instrument and flushing, then chances are you're going to encounter this issue. So let's say the person before you ran an experiment that used, I don't know, acetonitrile to hexanes. And then let's say your experiment calls for acetonitrile and methanol. Well, if there's any residual hexanes lying around in your lines, in your tubing, and in your column, that's really going to mess with your analysis. It's going to throw off your retention times, it's going to broaden your peaks, and it's just going to make your separation not ideal because you don't have the right solvent system in there. So polarity is key. So make sure you have the right solvents running through your system before you inject. Now the fourth thing that I want you to check for is any sort of leaks that may be in your lines. So if you have a leak in your line, let's say it's at a connection point to some tubing or where your column connects to your tubing, you'll typically see like a salt buildup or drippage of solvent that's coming from leaks in your lines. And that of course will be accommodated by some sort of pressure issues. But small leaks might not show up so much. So be cautious and look for these buildup of these salts that come out of these buffers. High temperature runs can degrade your lines. Volatile organic solvents like hexanes will definitely eat through those polymers. So just be good about double checking that. Now the fifth thing that I want you to double check is the freshness of your solvents. So you have aqueous buffers, you have organic solvents, you have acid buffers like acetic acid. A good rule of thumb is to replace your aqueous buffers every 48 hours, right? Because over time these can pick up carbon dioxide, they can pick up oxygen, and they'll change the pH. Your volatile organic solvents you want to replace every 7 days, because over time, again, those can give off solvent to the air. They can also pick up oxygen, and if it's an oxidizing solvent, then it will undergo oxidation, and that will change the whole polarity of your system, and that'll just mess up your run. So you don't want to do that. So again, check the freshness of your solvents. Now the sixth thing that I want you to look for is presence of any particulates or precipitates in your sample. And this is really important, especially if you're running a gradient in your experiment. So before you run your experiment, make sure you test the solubility of your sample in each of your solvents or for every gradient that you're running. And then also before you inject it, make sure you filter it through a 0.2 micron filter, because any sort of solid particulate that's in there, it can clog up your column, it can mess up your pressure and just cause a nightmare, and that's not anything that you want to go through. Now the seventh and last thing that I want you to double check is the purity of your standard solutions, right? So a lot of times you can order a standard, whether it's a solid like tyrosine because you're looking to develop a standard curve or something like that. Well, you need a way to gauge purity because mistakes happen, and sometimes starting materials don't come in and they're not pure. So whether you run an NMR on a solid to look at the purity, you can do that. You can also spot it on a TLC, or you can run it on your HPLC before you do your actual analysis. But some quantitative way to ensure that you have pure standard materials. That's really important to the success of your run. So if you want to learn more tips and tricks, you can check out this full blog on our website called peakfits.com. And if you're in need for any HPLC parts, PeakFit specializes in the manufacture of tubings and fittings for your HPLC machine. They're manufactured here directly in the US, so they're small enough to know you, large enough to serve you, so you don't have to worry about supporting overseas people. We support local, we support US made. So that's all I have for today. Stay tuned for future videos, and if you have any questions, just shoot us an email over to info@peakfits.com. Again, that's info@peakfits.com. And if you're in need for some high performance thermoplastic parts that are quality made, durable, tough, look no further and visit peakfits.com. Thank you, everyone. Bye.